So how can we address using animal manure in a way that would possibly reduce the contamination on produce? And here I have a couple of examples of survival of pathogens in manure. And you can see in the left hand we have E. coli 0157H7, which is a pathogen that I talked about last week. And it's split up into soil, manure, and other. And you can see just in soil, if you were to inoculate soil with 0157H7, it can survive for 50 to 150 days or more. And this has been shown in research labs and then also by inoculating onto research plots. Now in manure, you'll see at 5 degrees, so at fairly low temperatures, a little bit above freezing, E. coli 0157H7 can survive for about 70 days. But then you'll see as you increase that temperature, if you increase it up to about 37 degrees Celsius, the survival decreases a little bit down to about 48 days. However, that's still a pretty long length of time for it to survive. And then in water, in the other section, you can also see E. coli inoculated into water. So if you were to put some of the bacteria into water, it can survive for 25 to 250 days or so. Salmonella has a very similar story. If you were to place salmonella on the soil, inoculate it onto the soil and incorporate it, it can survive up to 300 days. So that's almost a year in the soil. If you remember, I talked a little bit about the hurdle effect. And this shows that as you start to manipulate different conditions that these bacteria are surviving in, you can manipulate the survival as well. So you see here that if you increase the temperature a little bit, it makes the bacteria more uncomfortable. It can't produce the energy that it needs to survive in those temperatures. So that way you can start to minimize the survival and start to try to kill off those pathogens a little quicker. And you can see from these numbers it also depends a little bit on the environmental medium and water availability. In water, these tend to survive a little bit better than in hard soil or very dry powdered manure.